Dropping the ball precisely on the Marble Machine X is a more complicated problem than what you might think. My goal with this episode is to try to explain as clearly as I can the premises for this engineering problem and to give you a full background of the requirements for the marble release on the Marble Machine X. I get a lot of questions from viewers that tells me that not everyone is on board on some of the very basic functions on the Marble Machine X. I hope that no one who has been watching this video and paid attention, mind you, will be left in the dark afterwards. By the end of the video, I will test for the first time if the Marble Machine X can play tight music. This is a make or break moment. If it works, we're basically on the home stretch. If it doesn't work, it's back to the drawing board. Later in this video, I will also build the prototype for this release. But before we go to that, I want you to really be primed in your understanding of the problem. So let's start right away by taking a thorough look at the design requirements for the Marble Machine X marble release system and the solution that makes dropping the ball precisely possible. Marble release design requirements 1. The marbles must be able to hit the same exact point from two different drop positions in order to repeat the same note in fast succession. Da-dun, da-dun. On the Marble Machine X, we have doubled the channels, which means we have 38 mechanical channels feeding marbles to 19 sound sources. This has the result that we need to drop marbles from two different physical locations onto one hit point. This also has the result that we can't drop the marbles straight down. We need to create a controllable arc for the marbles to fly at an angle so they can be on two different physical starting points and hit the same point. This is because we want to be able to play the kick drum or the snare drum or the vibraphone pling pling. Okay? 2. The two drop points needs to be as close to each other as physically possible. 38 channels is a lot, so in order to not make the Marble Machine 1 million meter wide, we need to keep it tight. And also, when we release marbles from two different drop positions, they will create a kind of an X pattern when they land on the same point and then bounce off in different directions after the land. And in order to keep this X pattern as tight as possible, we need to have the drop points tight. This will make it possible to build the funnels that will catch the marbles smaller, which is a good thing. 3. Because of the available space, the marble release cannot be wider than 28 millimeter, which is the equivalent of 3 pence. But smaller is better because there need to be room around the marble releases to be able to adjust them sideways. So we have decided to try to stay within 21 millimeter or 2 pence for the width of the marble release. 4. The marble needs to fall with the same arc and timing regardless of music tempo. This is tricky to achieve because when the machine plays slow, the gate that drops the marble opens slower than when the machine plays fast. 5. The release must be adjustable in every direction to precisely control the marble hit points. 6. The release must be adjustable to control the marble timing to make the music tight. 7. Solution must be manageable to build and assemble from time and cost perspective. 8. Repeatability. The marble must drop in the exact same pattern every time. 9. It must be durable and reliable for the World Tour. And 10. It must look cool. Yeah. That's a lot of requirements. Every single one of these 10 items on this list is a must-have, and this is where our journey begins. This is the first serious marble release prototype for the marble. Okay, let's try that again. It was supposed to work like this, with a fork in the front. The fork's position is adjustable here. The spring tension is adjustable here. And the fork is good for tuning your instrument. Let's analyze this to see how it does against our list of requirements. Can the marbles hit the same point from 2 drop positions? Yes. We can put these points close to each other and hit the same spot. But look in the back here. This is not 28mm each. They take up a lot of space. So the third channel coming here has nowhere to go. If we open this fork slowly, as in a slow tempo, we open, the marble is still not released. So the marble is released from this position. If we play fast, the marble is released from a completely different position, changing the arc, changing the timing, depending on how fast we play. This is only adjustable along one ground plane, but we need adjustability in all axes like this. 1, 2, 3, 4, 5, 6,
7, 8, 9, 10, 11, 12, 13, 14, 15, 16, where's the spring?
17, 18 parts. 1, 2, 3, 4, 5, 6 manually machined and tapped holes and a lot of welds. Building this times 38 is a small little YouTube series in itself. So I realized that a horizontal approach like here does not function for space management. And I tried to mount one of these almost 90 degrees this direction. And I realized immediately that a more vertical approach is the way to go here. Let's look at the results. Room for improvement. So here's a visual guide for you to make it easier to see the original marble machine. The original marble machine also uses a vertical approach. And I think it was this vertical approach that was stuck in my head when designing the release for the Marble Machine X. So here is a good example of the precision and care by which this machine was finally crafted. And you can also see that the slightest little motion on this thing in and out completely changes how fast this marble will fall. Keep that in mind until later. The highest note is missing. I think I know where it is. I saw the highest note lying in the giant box the other day. Yeah, there it is. I also found the black marble, my friends. So the black marble lives on. Probably one day it will be back. So now the work with designing a completely new vertical marble drop started. I started work with these bendable metal rods, and as you can see here, I measured how consistent they could hit the same point. And dropping 20 marbles, they all hit within a circle of 5 millimeters. I was really excited. And this is my first CAD designs with the metal rods for a new marble release. And I also took into account with these designs how to reach different instrument hit points. The obvious disadvantage with this design is that the marbles would be lost in a forest of metal wire. Chris, the project manager, had a completely different idea that he presented. Chris suggested to drop the marbles from within a PMMA pipe, attached and adjustable through a ball joint, like a nozzle kind of. And then he sends these beautiful renderings. And what I really took impression from these renderings was how clean everything looks. And it's a little bit false picture because, as I said, the instrument drop points is not in a straight line, so it could never look like this on the real Marble Machine X, and it didn't really work. But seeing Chris' renderings of this idea made me inspired to try to tweak my idea further. So together with feedback from the team, I went on a design crusade to try to make this thing more elegant. There's a lot of functionality that this solution needs. The lifting finger needs to be guided, there needs to be some kind of spring to really keep it at the exact same position, and there needs to be registering so the marble always sits perfect. I tried to design it like a 3-legged stool so that the marble would stick between 3 points. Then I started to work on the transition bar that connects the PMMA pipes to the metal rods, and here you can see how it's built up. This is designed to make the metal rods easy to adjust. So if you see here, there's a side that you can push with the M6 bolts onto this part, and with the friction the metal bars will be really held in place. But if you loosen up the screw, you can easily adjust it. And on the back side of this rod, I made a hex shape, so it's a one-hand operation to adjust the rods. And this is a really nice solution from Chris in his design for how to include the adjustability. By having this slot, you can adjust the marble drop like 30 to 40 millimeters height-wise. After several rounds of simplification, we landed on this, and this uses 3 parts and 2 springs. No welding, no tapping, no nothing. So it's quite amazing that we went from 28 parts to 3 parts. And that was all thanks to that Chris forced me to better my original idea from this to this. Let's look at the results. Time to make a prototype of this. So here's the old programming track that utilized these round programming pins. Now I'm attaching this new programming track with 3 tracks per track, and it utilizes these rectangular magnets. Love that sound. Listen to this. Chris has told me that I'm not allowed to chase perfection because it doesn't exist. I just proved him wrong. Okay, this is where the real experiment begins. I'm first going to measure consistency in the marble drops. So I put 4 programming pins on one channel, and I'm gonna sync them up with the internal click. Just so you know, the Marble Machine X is not going to be played with a click like this. The click is only there to get consistency in my experiment. I'm using 120 BPM, so if you hear a difference between the Marble Machine's click and the computer's click, don't worry so much about that. That's not what we're measuring right here. Also, I'm sure you noticed that the marbles are not falling on top of the click. That's also not what we're measuring right now. We have an adjustment system to sync the marble drop with the click later. That system is not in place yet, and it's not what I'm measuring right now. So don't worry about that. So I record this into 2 audio tracks. This top one here is the physical Marble Machine X click, and the below one is the marble drop plywood plate. Let's listen. At this stage, the plywood drop is not synced with the click, but that's not what we're measuring. So I'm syncing up the first hit of the marble drop with the click. Here you can see it's sample accurate. And then we're playing it again. Now we can check for consistency between the physical click and the marble drops. I'm not really sure how tight the physical click is, so I'm not really sure how much we can read out from these results. But if you check the top value on the left here, you can see that it differs 8 milliseconds between the click and the marble hit on the second hit. For reference, 1/16th note in 120 BPM is 125 milliseconds. So 8 milliseconds is in between a 128th note or a 256th note of the music. It's very, very short amount of time. Let's check the third hit over here. There we can see that it differs 78. That's tighter, that's 5 milliseconds. And let's check the last hit. That looks very tight. Yeah, that's it, within 1 millisecond. So as I said, I'm slightly unsecure about how tight the click is, so we cannot really read in too much from these results, but my gut feeling is that this consistency is actually impressive. Here is the same test in 80 BPM. When I check the audio recording in the computer, I kind of expected the machine to do worse in 80 BPM. But what a pleasant surprise to see that it actually did even better. (160 BPM). As you hear, it does handle 160 BPM pretty well. But I think we're really touching on the limit on how fast we can repeat the same note with one channel. Let's go back to the same footage of 160 BPM, and then you will see that the marble is just finding its resting position before being dropped. Check that out. And this is a perfect illustration to show why we are doubling up the channels. With the marble lock positioned that high as we have it, it takes quite some time for the marble to reach resting position before we can play the same note with the same channel again. Okay, let's move on to something really serious. Now I'm attempting to get 2 channels drop a marble to hit at the exact same time. So you can see here I'm putting programming pins next to each other. So this test will really tell us if this marble release solution is valid or not. This group is channel 6. This group is channel 7. The outer line here is straight notes. The middle line here is 32 offbeat notes. And these 2 out here is triplets together with the first note from the straight notes. Simultaneous marble drop test 1 without any adjustments. I realized immediately that I should split the hit surface and record 2 separate channels to really be able to analyze the time difference between the 2 marble hits. So I aimed each marble release at their own plate. And I put on a new contact microphone, so now I'm recording the click plus marble release 1 and marble release 2 separately. First test, double drop, and no, that Wintergatan sign is not going to be there on the final Marble Machine X. Checking the audio recording. We see very clearly that the second channel is earlier, but it's consistently earlier, which is exactly what we want to see. So I'm trying to compensate for this by raising the drop point for second channel. And here you can see why I want a one-hand operation on the real thing. This is the prototype. So here I'm really lacking one hand when I need to hold the lock nut in the pliers with my left hand. So that's why I made that hex shape that I showed you earlier. So I can use my right hand with a hex key and my left hand can hold the marble release. Second try. We don't even have to analyze the audio recording to see that the second channel is still early. Let's do some more manipulation. So I'm doing the manipulations by bending the metal rod, and real engineers hate this method. They don't want stress in the metal. It's just that in the marble run culture, bending metal wire is part of the lore, so to speak. That's how you build marble runs. And on the real deal, which is not the prototype, we will be able to manipulate by not bending as much of the metal. So I hope you real engineers out there forgive me. This works. That's what I want to say. Third try, and with this zoomed in picture, you can clearly see that there's quite a lot of shaking of the top of the machine. And I have several improvements to prohibit this for the future, because that's important to fix. Second channel, still clearly early, so I'm lowering the resting point for the first channel. Fourth try. Less early, but still early. It's time to look at another place in the machine where we have designed adjustability for this kind of issue. If you look carefully on the 2 registrators here, you can see that the left of the 2 is moving before the right, which is exactly what we would expect since the second channel was early. We have a fix for this. If I perhaps disappointed some real engineers with the metal bending earlier, I hope I can gain back your trust and that you can forgive me when you see this solution. These are specially made laser cut 0.1 thick shims. So these fit in perfect under the registrators. So here I'm introducing 5 shims for a spacing of 0.5mm to make these 2 channels activate simultaneously. Fifth try. Well, that sounded very unison. Let's check the audio recording. Before the shims. after the shims. We're getting there, but I'm not done tweaking this yet. So when designing this marble release, one of the most essential things was that I wanted the marble to end up in the same position, very repeatable. So if I drop one, this one should be in the very same frame. So let's drop some more, and then we can compare the frames. First marble was here, and second, and third, and fourth. Not a big difference. Sixth try at 25% speed. At this point, I realized that one of the legs of the machine was hanging in the air. You can see how loose it is here. So a couple of turns with the wrench and the machine is so much more stable. This is the 8th try. And let's check that audio recording because that sounded correct. Okay, that's unison. Let's check the milliseconds. What do we have on the first one? 3 milliseconds difference between the two marbles on the first hit. Let's check the second hit. Where are you there? That's tight. That's 1 millisecond. And let's check the last one. 2 milliseconds. If you're used to work with music and you know about transients and stuff, you know that this means that the Marble Machine X can play tight music. Let's take a moment for that to sink in. The Marble Machine X is tight. Ow. Diggy, 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 diggy. There. 1, 1, 1 is... I'm not really used to these patterns yet. I'm going to be fast at this later. So just for fun, I'm going to EQ one of the channels like a kick drum and the other channel like a snare drum and EQ the click as a offbeat hi-hat. First room sound. Contact microphones, no EQ. Add EQ. Add delay. Add matchbox shaker. Add guitar.